Hey y'all, just put together one last video on converting polar. Last video we kind of came up with our arsenal of equations that we can use to substitute and convert when we're talking about coordinates, and we're now going to actually use these to convert an equation from polar to rectangular or vice versa. So let's get started. This first question I have here is a rectangular equation of a parabola, and I am going to convert it into polar. So first off, we are going to just substitute in our two equations that we have for y and x. So we have y is equal to r sine theta, and x is equal to r cosine theta. So we can substitute like that. I'm going to clean this up a little bit here. I've got r sine theta on the left side still, but the right side, if I square both of those expressions or terms inside, I get r squared cosine squared theta. In terms of polar equations, kind of think about r as our dependent variable and theta as our independent variable. So I need to solve this for r. To do that, what I'm actually going to do first here is I'm going to divide by r on both sides. And now we have an equation with sine theta equals r to the first cosine squared theta. And if I want to solve this for r, now I can divide both sides by cosine squared theta. And so when we do that, we get r equals sine theta over cosine squared theta. Totally a valid option as an answer. Some might kind of see this as a nuisance trying to put this into the calculator. So we could actually convert this by viewing the sine over cosine squared as sine theta over cosine theta times 1 over cosine theta. So that's really just pulling apart that fraction. Then we can kind of see that sine theta over cosine theta, well, that's just tangent of theta. And 1 over cosine of theta is secant of theta. So we get r equals tangent theta secant theta. And if I put that in the calculator, or if Desmos or whatever, we can end up getting a parabola. Next one's kind of an easy one. It's just direct substitution, x equals 4. And if I go ahead and substitute right away, x is r cosine theta. And again, since our graphing formats are defined with r, I need to solve for r. I'm going to do that by dividing both sides by cosine. And we end up getting r equals 4 over cosine theta. And an equivalent statement, probably more likely to see this for secant theta. Again, just because 1 over cosine is the reciprocal function for secant. All right, so those two aren't too bad. So let's get to kind of a unique one here. Convert into rectangular form and describe the graph of theta equals pi thirds. I'm actually going to think about this one graphically first. All right, so we're just going to kind of think about the picture. If we graph theta equals pi thirds, well, pi thirds is an angle, and it's an angle in the first quadrant. And in terms of degrees, it'd be 60 degrees. So that's what theta equals pi thirds looks like. Okay, that angle there is But when I say that theta is equal to pi thirds, I didn't really specify what r is, right? So r could have also been negative, right? When we talked about coordinates, if r was negative, the point just kind of jumped backwards into the opposite quadrant. So the equation for this is actually going to be some sort of line, y equals kx, where k is the slope of the line, and there's no y-intercept, or the intercept is 0, so I don't have to have a plus b at the end. All right, so let's talk about what k is. And we're going to do that using the definition of tangent of theta is equal to y over x. Right, that was one of our formulas we had on the previous page. So tangent of theta, well, theta is pi thirds, right? So tangent of pi thirds is equal to y over x. And tangent of pi thirds, well, that's just one of our special angles. So the tangent of pi thirds is radical 3. So radical 3 is equal to y over x. Right, that's just a substitution there. And if I want to solve this for y, I'm just going to multiply both sides by x. And then I get the equation of the line. And so we can say that it's y equals x radical 3, or since I wrote it as kx over there, we have it as y equals radical 3x, just again make sure that that x is outside of the radical. Okay, so the last one here is one that's going to take a little bit of work. So what is the shape of the graph r equals 4 cosine theta? So in one of the videos we talked about how that's going to be a circle. Since it's cosine, it's going to have symmetry over the x-axis, and the 4 is essentially the starting point at theta equals 0. The graph is 4 units out, which means that I have a circle that's going to look like this, where the radius is technically 2, right? That's the radius there. And so we're going to essentially derive this equation. So we have r equals 4 cosine theta as our equation. So the tricky part to this one is it takes a little bit of creativity. It's not an obvious first step, and if you forget it, it's very difficult to transition into the actual conversion. So the trick is to take the original equation and multiply through by r. So when I distribute that r in the left side, we get r squared. And then the right side, we get 4r cosine theta. Now, we already have r squared defined as x squared plus y squared. That's one of our conversion equations. And then for r cosine theta, well, that's just x, so it's 4x. Now, pertaining back to our conics unit, I could just put that into center radius form by completing the squares. We have x squared minus 4x plus blank plus y squared equals, well, I subtracted that 4x over, so now it's equal to 0, but I have to, add the blank on that side. And I get 4 and 4 as the magic number. And then this converts into x minus 2 quantity squared plus y squared equals 4. So we get our circle centered at 2, 0, and a radius 2, as kind of verified by that picture right there. All right, hopefully that's kind of enough to get you through, all the different kinds of conversions. There's some more challenging questions as you go further into the packet, but, the rest of these strategies should be, or at least the strategies I've shown you should be sufficient to help you answer these questions. All right, bye.